Okay, this is the Cartesian plane, the origin, which is this one. And now we are going to introduce to you, or I'm going to introduce to you another approach, which is the parallelogram method. So going back to the problem I have introduced previously. So with this problem now, so to review, the given was 120 Newton directly. The direction is towards to the right along X, and we also have 250 Newton inclined at 30 degrees and 200 Newton oriented vertically upward, and the last force, which is 300 Newton vertically downward. So again, we have to use this problem to solve for the resultant, but with another method, which is the parallelogram method. So we will start this by setting the scale to 1 centimeter as to 20 newtons. So to plot this 120 newton, we need how much centimeters in length? We need 6 centimeters. So therefore, we can now plot this on the Cartesian plane. We have 6 centimeters. So 6 centimeter on the Cartesian plane, we shall have a reading of 7. Here. So this is your 120 Newton. Then let's have it darkened. Okay. On the line. So that's the first vector having a magnitude of 120 Newton, which is equivalent to 6 centimeter in length. Next is 250 Newton inclined at 30 degrees. So inclined at 30 degrees, we have to establish 30-degree line. So we have to establish this first, the vertical line. Okay. We have this and 30 degrees. So project this line now. So this is now the 30-degree line. So 250 Newton will have an equivalent of here, equivalent to 12.5 in length. So 12.5 so 12.5, so it shall have a reading of 13.5. Okay. Then darken it. So that's the 250 Newton, which is equivalent to 12.5 centimeters. Next is 200 newtons. The 200 newtons will have a length of 10, no? This is 10 centimeter. So we'll have it here. It must have a reading of 10 centimeters. So we'll have here set at 11. Then mark it at 1. Okay. So that's the vector. That is the 200 Newton, which is equivalent to 1 to 10 centimeters. Okay, so you have noticed what's the difference between the parallelogram method compared with the closed polygon method. You have to place all the vectors here, starting point all at the same time at this point. So we have one more, which is 300 Newton, which is equivalent to 15 centimeter. So we shall have it plotted here. So 15 centimeters. Okay. So by doing so, we have 15 centimeters. This is the point here. 16. So we'll have it then darkened. So this is it. So the 300 Newton equivalent to a length of 15 centimeters. Okay. So if you try to see the entire figure, this is now the overview. Okay. So the first thing we have to do is to draw parallel lines, 250 here. Okay, and then parallel also to this. So all you have to do is to come up with the parallel line by taking 30 degrees. So we will try to check if this will really have 30 degrees inclination. Okay, so it fits 30 degrees. Okay, this 30. Draw a parallel line now here at the tip of this line, 120 Newton. Okay, this 120 Newton, if you try to see, so you just have to place this point here. You just draw this, then have it right there. So just draw 30-degree line. Here we go. So you have now this parallel line. This one, which is, this line is parallel to this. And this, you have to make another free vector and place it here, which is held horizontally, straight. Then what shall we do? All we need is to do this. So we have to make this line now. Take note, this is your x, the x axis, and this is your y axis. Okay. So the next, is to establish